This is over algebra representation, multiple representation, part 1. So, perimeter train. So that gets us to our lesson for today. In our lesson, you are going to be given a figure. You're going to be given a table. You will make a graph from the table. You will find the equation from the table. And then you're going to decide, is it additive or multiplicative? And which side is the dependent and which side is the independent? So in figure 1, we see 2 squares. 1, 2. In figure 2, we see 4 squares. In figure 3, we see 6 squares. Can you make a prediction as to how many squares there will be for figure 4? But let's make a table first. I see in figure 1, where is mine? In figure 1, I see 1 square. So figure 1, there are 2 squares. In figure 2, there are 4 squares. In figure 3, there are 1, 2, 3, 4, 5, 6 squares. If I had to make a prediction for figure number 4, I predict there will be 8 squares. So if we created a graph from this, we will use quadrant 1 because these are positive numbers. I will label the x-axis, y-axis. Again, in graphs, you've got to label the axis. These are about the figure numbers. And these are the y-axis will be the number of squares. So this will be 1, 2, 3, 4, 5. And I'm going to number this by 2s. 2, 4, 6, 8, 10. So in figure number 1, choose a different pen color. In figure number 1, there are 2 squares. In figure 2, there are 4 squares. In figure 3, there are 6 squares. In figure number 4, there are 8 squares. Figure 5, I make prediction there'll be 10 squares. What if I had figure 0? Would there be any squares to be had? None. 0 squares. So will we connect the dot or not? No, you will not connect it. So it is not continuous. It's called discrete. Discrete means each one of these represents its own itty bitty dot because we can't have half of a figure. I don't want a fraction of a figure. I want figure 1, figure 2, figure 3, figure 4. So that is my graph. So I made a table. I made a graph. Now let's see if we can find the equation. What's the relationship between 1 to 2, 2 to 4, 3 to 6, 4 to 8? The relationship is times 2. So the equation will be x times 2 equals y. Another way I could rewrite that is y equals 2 times x, or y equals 2x. So my equation is multiplicative. I had to multiply by 2 to find the number of squares. So to find the number of squares, you multiply the figure number by 2. Now, which side is the dependent and which side is the independent? Let's think. Which one makes more sense to you? Does the figure number depend on the number of squares, or does the number of squares depend on which figure number? the second one made more sense to me. So this is the dependent and this is the independent. Again, for those who have issues like I do, I'll admit I have issues determining which side is the dependent and which side is independent. In science class, you may have learned from your science teacher something called dry mix. Dependent, independent. Dry means dependent responds to the manipulation of the independent. If you manipulate or change the figure number, the number of squares will depend on that. So let's look at our next example, another perimeter train. So in figure 1, I see 1 square. In figure 2, I see, oh wait, this table is about number of triangles and perimeter in inches. So this is each side represents 1 inch. Figure 2, you have 2 triangles. Figure 3 has 3 triangles. Again, what is the definition of perimeter? Perimeter is the distance around the figure. So, using my pen, Control 2. I wonder if that's faster. Control 2 instead of me trying to come up here. So, number of triangles. Figure 1 has 1 triangle. Perimeter is 3. You get a ruler and measure each side of this triangle. 1 inch plus 1 inch plus 1 inch is 3 inches. Figure 2 has 2 triangles. 1 inch plus 1 inch plus 1 inch plus 1 inch is 4 inches. Before somebody say, but what about the inches here? Again, perimeter is the distance around a figure. Figure 3, 1, 1, 1, 1, 1. Figure 3 has a perimeter of 5 inches. Figure 4 has a perimeter, let's make an estimation, of 6. If I had to draw this, 1, 2, 3, 4. It would be 1, 1, 1, 1, 1, 1. So create a graph. This is the X. This is the Y. This is the number of triangles, X. This is the perimeter. Again, you got to label the axis. Oh, number is what? 0, 1, 2, 3, 4. And I'll number this by 1, 2, 3, 4, 5, 6. Let me use a different pen color. So number 1 triangle will have a perimeter of 3 inches. 2 triangles will have a perimeter of 4 inches. 3 triangles will have a perimeter of 5. 4 triangles have a perimeter of 6 inches. So do we connect the dot or not? Is it continuous or discrete? Continuous means it continue on. Discrete is just each individual one. This is going to be discrete because I'm talking about each triangle. I'm not doing like a quarter of a fractional of a triangle, 0.001 of a triangle. So now let's find the relationship between the number of triangles and the perimeter inches. The number of triangles is +2. The relationship is +2. I'm adding 2 to the number of triangle. And what variable is represented by that? X plus 2 equals y, or y equals x plus 2. So it's additive. And which side is the dependent and which side is independent? Which one makes more sense to you? Does the number of triangle depend on the perimeter inches? Or does the perimeter depend on how many triangles we have? That makes more sense. So this is the dependent, this is the independent, this is the dependent, this is the independent. So through this, we just did multiple representation. You are given a table, a graph, and the figure number. You are able to answer these questions. This is the video of multiple representation part 1.